extensive national and international experience in ocean science, environmental issues, and global climate. She is Vice Chancellor for Marine Science, Director of Scripps Institution, and Dean of Marine Science at University of California, San Diego. She is here promoting the importance of understanding and protecting the planet, an activity that we are trying to develop in this institution. What we can see in her CV, she is a hardworking scientist who has been committed to her job and ideas since her early life. The list of her work positions in different prestigious investigations is almost endless. That's why we are very pleased to welcome PhD Margaret Leinen.
Thank you very much. This is my fourth trip to Argentina, and I've been to San Telmo before, but I've never had an opportunity to talk to people from a school, and so I'm very excited about that. When I was asked by the embassy to talk with you, they asked me to talk about what it was like to be a scientist and how I became a scientist. And so my remarks are focused on that rather than on environment, but I'll be happy to answer questions about environment as well. So when I was your age, I wanted to be a lawyer. And it was because of a very popular television show in the U.S. at the time. And it had a lawyer, and of course he solved everybody's problems. Every case, every law case he won. And he was so different from my family. As I say to people, he drove in a convertible car, you know, up down. He drank cocktails. He wore a sport coat, and he had a secretary, and he fixed everything. And I grew up in a medium-sized town in the middle of the country, and my parents owned a small store. And so I thought that was when I was in grade school, grades 1 through 8 in the U.S. I thought that was very exciting. So I told everybody I wanted to be a lawyer. Then I had a remarkable set of high school science teachers. And we had a lot of science in my high school. Not as much as you have here, but we had certainly chemistry and physics, but also geology and meteorology and some other technical sciences. And I was so impressed with my teachers because of the way that they taught me about science. They taught me, we would have a class, but then when something happened in the world that was related to science, they would tell me exactly how it was related. And I can still remember, for example, a day when, at the time, the President of the United States had a heart attack. And everybody was talking about this special drug that he was given for his heart attack symptoms. And my biology teacher just took that apart, as we say, unpacked it, and talked to us about why a drug would help a heart attack. He diagrammed the chemistry, the chemical formula on the board. We talked about how recently that drug had been developed, and that it was a result of science and technology that the president was being helped. And every other aspect but I was still a little uncertain about what brand of science I wanted to be in. So every semester I would fall in love with another kind of science. And so first I majored in biochemistry, and then I majored in microbiology, and I went through 3 or 4 different sciences before I wound up in geology. And so my undergraduate study was geology. And that brings up one of the other things that I love about science. Unlike so many fields where most of your study and most of your work is in an office with papers and so forth, much of science brings you in contact with the real world. So we had many field trips all over the U.S. For my geology major. And if it wasn't out in the field, it was in the laboratory. It was an opportunity to really physically be doing something as well as just studying. And that's one of the things that I really love about science, that sense of experimentation and that we don't know all the answers. And I look at things that were in my textbook at the time, and for example, in biology, so much has changed. At the time that I went to school, we didn't know how DNA worked. We didn't know about molecular genetics. We didn't know about the human microbiome and the fact that of the cells in our body, most of them are something other than us because they're bacteria and viruses and so forth. So it's not done. There's a lot of work to be done, and there's a lot of work for you to do. And that's another thing that I really love about science, that we don't know the answers, all of the answers yet. And there's lots of room for all of you to contribute to the way that we understand the world. When I graduated from college, I had been studying geology, and I studied the geology of sediments, the rocks that form in the water from rivers and the ocean and so forth. And at the time, we knew a lot about deltas and rivers and beaches and coastlines, but we didn't know so much about the deep ocean. And this was the whole discovery of plate tectonics and the way that the big continental plates move and the evolution of the Earth. And those papers had just been published when I was in college. And so we were just beginning to understand that. And I said, in order to understand the evolution of the Earth and the rocks, I should go and study the ocean, because that's where this is all happening. So I went into oceanography. Another piece of what I have loved about science is the opportunity to talk with people all over the world. I know very, very few scientists who don't depend on science that's done by scientists in other countries and around the world. We all read published papers by scientists around the world. There are so many opportunities to go to meetings all over the world. And as I said, I've been in Argentina 4 times. Each time has been for a science meeting. And that ability to get to know people around the world is also very characteristic of science. It's very international. And as we say in the U.S., science is a team sport rather than an individual sport. So there's lots of opportunity to work together. That's another piece that I really like. A final piece that I want to mention is the range of jobs that are available in science. Certainly there are a lot of scientists that are in universities like I am, but there energy. All of those policies are informed by scientists who are working in government as well. And then finally, there's the private sector, the businesses here and around the world who make products for us that are important, whether those are new kinds of, the plastic in this came from scientists and chemists who developed new kinds of plastic that were very tough enough to be on here. And, well, we probably couldn't drop it on the floor, but that actually probably has more to do with the screen than it does with the case. But also processes, many, just some very famous ones. The scientists who developed the process by which we can take nitrogen out of the atmosphere and turn it into fertilizer that means that all of us have very inexpensive food. Those processes as well as products are incredibly important, and they've given us the quality of life that we have. So many kinds of jobs in the private sector as well. And now there are a whole new range of jobs that are opening up for scientists that have to do with communications, because we've never been as connected. Or I saw the Twitter feed going up here, and all over in the communications industry, people are asking for scientists who understand and can translate what we do in science to everybody. So that's another piece that I like. And the last thing that I want to mention is how people respect scientists. They respect the fact that we use the scientific method, that we are focused on things that can be demonstrated rather than just opinion. And they respect the fact that scientists have invested so much in their understanding of the world. So around the world, when they do polls of the general population, and they say, how much do you respect people in this kind of job versus others, science always is very close to the top. Unlike lawyers, remember that was the first job that I wanted to do when I thought about that. So, and I just wanted to mention, we are celebrating International Women's Day, and I was asked to feature some women that I know that are famous scientists. So I'm going to mention 5 or 6 that are personal friends. One, Dr. Catherine Sullivan. She just stepped down from being the administrator of the National Oceanic and Atmospheric Administration in the U.S. But before that, she was a geologist. And before that, she was an astronaut. So she and another friend who just recently died, Dr. Sally Leinen, were the 2 first women to walk in space. And Dr. Sullivan was the one who fixed the Hubble telescope. The Hubble telescope was an international effort to put a huge telescope into space. And when they got it out there, they found that there was a problem with the mirror that is the guts of the telescope, and it was sending back fuzzy images. So there was a huge 3-year process to develop a new mirror and put it into place. And Dr. Sullivan was the one who walked in space and actually put that new mirror in adjustments into the Hubble telescope. Another wonderful friend is Dr. Jane Lutchenko. Dr. Lutchenko was also a former director of the National Oceanic and Atmospheric Administration, but she has been deeply involved in diversity and in the worldwide effort to establish marine protected areas. So like national parks, but in the marine environment. Another example, Dr. Vera Rubin, a close friend of mine from the time that I was at National Science Foundation. And Dr. Rubin's work was some of the first work that showed us that there was energy in the universe that we hadn't taken account of. And this led directly to the concept of dark matter in the universe. She's a member of the National Academy of Science, or was. She died this last year. And finally, I wanted to mention a different kind of scientist, Dr. Ellen Williams, also a physicist, who moved from physics into energy. And she's been responsible for the fostering of new kinds of renewable energy in the U.S. So all of these are women who took their basic science career and did something extraordinary with it. And that's something that all of them can do as well. So I'm going to stop there, and I know that I was asked to leave plenty of time for questions, so I'm happy to answer questions about careers in science, but also about that theme that you saw in the title, Understanding Opportunity. Thanks so much for being here.
Si alguien necesita ayuda con la pregunta para formularla en inglés, simplemente la dice en castellano y lo ayudamos.
First of all, nice to meet you. I have two questions, both are different. The first one is about the things I have to study. Because now I'm studying the whole building things. When I get older in 2 years, I have to decide if I want to be an engineer or an architect. The problem is that design, I love that. I love, since I was a child, I was drawing houses. The problem is that I love quantum physics. Yeah? I love that. But here in Argentina, it's difficult to get the work related to that. And I don't know, I have 2 years to decide, but I don't know from someone who has gone through the lawyers or the sciences, how can I decide what to follow? Because here an architect or an engineer has a future, has lots of things to do, and with a lot of money, but science is not. So that is the first question, how can I decide what I want to do? ways and lots of places where we can build something. What do you think about using that environment to use I don't know, for energy, for big places, for planets, or whatever, I don't know, some kind of energy.
So the last question was about using the open space for energy generation, solar, wind, etc. We're also having this conversation in the U.S. about where we would put large solar installations or large wind installations. Like the U.S., Argentina is a big country, and I think that it's one of the things that we found is that there are areas where people want to have those installations because they want to be part of the energy generation and they want the jobs that are associated with it. In solar, one of the things that's happening in the U.S. and I expect will happen more is that people are moving away from the idea of giant solar installations to more community, not individual, not just solar on my house, but community solar generation. And with the changes that are happening in that industry, I think that there's going to be a lot of new technology and new capability in the future. Thanks very much.
Thank you very much.
Whether the politics are good enough or not. What I would say is that that I think that everywhere we have really been going through a transition in trying to understand how to make our environments, to preserve environments, but also to be able to have jobs. And that's really the key to new thinking around sustainability rather than just environmental protection. Environmental protection doesn't have to be, but can be interpreted as you can't do anything in the environment. And if you can't do anything in the environment, then it's very difficult to be able to use natural resources. But the key is being able to find that balance between using natural resources and using them in a way that preserves the environment in the future.
Close.
The question was about the Fukushima nuclear disaster in Japan and how that affected the Pacific Ocean. The immediate effect was the release of enormous quantities of radiation into the Pacific Ocean. Some of that radiation is very short-lived. So it was, it's already gone. Other of that radiation is very long-lived, and there are two kinds of concerns. One is about the radiation that is in the water and moving around with the water. The other is about radiation in organisms. So there have been many studies of organisms, especially fish, out in the middle of the Pacific to see whether they have been affected by the radiation. There is evidence of radiation, but it is a very, very small amount, so small that it wouldn't affect us. That's for the Pacific Ocean far away from Fukushima. So that is not a danger to us. There is still, however, concern about the radiation very close to Fukushima. And of course, fish swim. They don't just stay in one place. So the question is, how much are fisheries in the area around Japan being affected by the radiation? So in Japan, there's a very active program of monitoring the amount of radiation in fish to make sure that any fish that are sold in markets are safe to eat. So that's one big effect, and how it's different in different parts of the ocean. The second is radiation in the water itself. One of the most important things is that there are the kinds of radiation that go into materials that are soluble and stay with the water. Most of that radiation is not very powerful radiation, and it's more like natural radiation that you just get from rocks. And the radiation that is around the area also has been incredibly diluted. So in spite of the fact that there was a lot of radiation, the amount of water in the ocean is incredibly big. And so much of that radiation is very, very much diluted. So there wouldn't be a problem or a safety problem being in the Pacific Ocean far away from the area right around the beach. So in a very close area, obviously a big problem, but much further away, not something that you have to worry about in terms of eating fish or being near the water. So the deep ocean is the nature of your question about things like deep sea mining or changes in the ocean related to changes in the ocean. Okay. What the deep ocean, and I'll define that as the ocean deeper than about 500 meters. Is most of the ocean, and it is also connected with the surface. So we know that the ocean is warming. We are now able to measure that very, very accurately. But because the ocean is so big, it's warming very slowly. Nonetheless, it is warming, and one of the things that we're trying to understand is what the implications of that warming are for ocean life. We're interested in sort of two areas. One is how will the warming affect the organisms in the ocean, like the small microscopic organisms that are the base of the food chain. And the second is, how will it affect the way that the ocean circulates? Right now, in terms of the way that the ocean circulates, we're not seeing major changes, and we're not seeing changes that would result in effects for us or for your generation. It could be changing the ocean in ways that would affect it hundreds of years from now, but not right now. The second is, what about the organisms in the ocean? We're definitely seeing the effects of climate change on that. And I'll give you a couple of examples. We're seeing fish that are part of fisheries, the kinds of fish that we eat, move from the areas that they were in, moving toward the poles. So moving south here, north in my hemisphere, and deeper. And we believe that that's because they want to be in cooler waters. So that means that the location of fisheries could move. It's not moving thousands of kilometers, but it's moving gradually. And of course that means that the place where we used to fish may not be the place that has the most fish in the future. So that's sort of an immediate effect, but we're definitely seeing that. There are lots of papers in the scientific literature about that. The second is changes to the microscopic organisms. And for this, there's much more uncertainty. We are just beginning to study how the microscopic organisms of the ocean may be affected by climate change. And then I'll mention one other thing that doesn't have to do with temperature, but it has to do with the acidity of the oceans. So those of you who have taken chemistry know that pH is a measure of acidity, and as pH gets lower, things become more acid. So the CO2 that is in the atmosphere, that we put in the atmosphere from burning fossil fuels, dissolves in the ocean. And just like agua sin gas has a higher pH than agua con gas, the pH of the ocean is going down a little bit. And there are places where we're beginning to see that impact shell fisheries like oysters, clams, mussels, and there are places where we're seeing it affect other organisms in the ocean, like coral reefs. So the thing that all of those have in common is that they make skeletal material out of calcium carbonate. And as the pH goes down even a little bit, it's harder for them to make that skeletal material. So those are the three impacts. Fish are definitely moving. Coral reefs and other things that depend on calcium carbonate are having a harder time making it. But about the big microscopic part of the ocean, we're not so sure. Sorry, it's a complicated ocean and a complicated answer. So there's a question about my experience as a woman in science. I started in oceanography at a time when it was difficult to be a woman working in oceanography. People were not familiar with having women on the ships at sea as scientists. And I had situations where it was difficult for me to go, that I couldn't go on the cruise. I had situations where it was difficult to do the work that I wanted to do. Fortunately, that time has gone almost everywhere. It's easy for women scientists to be able to go to sea through my life, I've seen more and more women in laboratories, more and more women at sea, more and more women doing science in school. And right now, applications to do graduate study in ocean science at my institution are 50-50. Just as many women as men applying, just as many women as men being accepted. So that's a good thing. But it's definitely been a story of evolution of people getting used to having women in science and women in the field. But I think that, you know, it's society evolves, and it doesn't evolve as quickly as many of us would like, but it does evolve. And I think that all over, even in some of the countries where it has traditionally been very difficult for women to be in science, for example, in Asia, we're seeing many, many more women, not only in scientific laboratories, but in business and in government. So my experience as a woman in science has been a wonderful one, and also it's been wonderful to be part of this big change. So lots and lots of women in science now.
I have some question from friend that is a bit shy.
Oh, okay.
So,
We know about this. I'm only asking for a friend.
well, the very first one is, why did you choose our school to visit? What did you choose to visit our school?
I was made aware of your school by the staff at the embassy. They have worked with your school over many years. And also, I was aware of the GLOBE program. Several years ago, I was at the U.S. National Science Foundation, which provides funding to GLOBE through NASA. And so I was very aware of the program and what it does. So I was delighted when the embassy told me about the school and that you were involved in GLOBE. And of course, you're a techie school. I don't think they would have invited me if it was a school for the arts.
Well, the next one says, is there any endangered species due to global warming? I think the major, I don't know, I think most of the species are endangered. I think they refer to the major ones.
So the question was whether there are species endangered by global warming. There are certainly species that people are worried about. Most of those are species that have restricted ranges and that are very dependent on certain temperature regime or certain amount of rainfall. I have to say there are many more species endangered by our activity in terms of altering their habitat. And we've done much more by hunting, by fishing, and by altering habitat that we're seeing now from climate change. Doesn't mean that it's not happening as a result of climate change, but so far the big impact has been us taking species, taking organisms out of the environment or changing their environment by cutting down trees or farming or any of the other things that we do.
Thank you.
You're welcome.
That was the last question.
Thank you very
Thank you
much.
very much, Margaret, for your conference and for coming and visit us. You are an inspiration for our children and especially for our girls. Thank you.
Thank you so much.
escuchan bien?
Bien,
I want to thank the Instituto Huergo for hosting us today, for getting this amazing group here. Thank you all for coming to listen to Dr. Leinen, and thank you for Dr. Leinen. This was her first activity on this trip in Argentina. She arrived yesterday, had a long trip, but we're very, very honored that she's here with us this week as a science envoy. It's a national science envoy program that we have with the U.S. government. And while we're here, I have to take advantage of the opportunity to share a little bit about the programs that we have at the embassy for people your age who are particularly interested in STEM, science, technology, engineering, and math. Has anyone heard of the National Youth Science Camp? Anyone? No one, okay. Then you're the perfect audience. So on Sunday, we just closed the call for applications, the convocatoria for this program, which is the National Youth Science Camp, held every year in the state of West Virginia, in the United States. This camp is specifically for young people in high school, like yourselves, who are interested in learning more about the sciences in a camp setting. So it's a month-long program which is held every year during your winter break, so summer in the U.S. And every year we send 2 Argentine students there to West Virginia. It's at Camp Pocahontas, it's called, where you get to learn a lot about science and IT. You get to meet with professors and distinguished scientists. And you also get to do lots of outdoor activities, so like rowing or hiking or archery. There's lots of opportunities to do activities. And it's held with students from the United States and also other students from Latin America. And you all already meet